Hello everyone, welcome back to Shikara Academy. So this is your prelims crash course for 2026. In this series, I am going to discuss all the important topics which are relevant for your prelims 2026 examination. So in our first video, we are going to discuss the pressure belts and the planetary winds. We'll also discuss some of the local winds important for exam. Right, so let us start without wasting any time. Before going into topic, I would like to announce that Shikara Academy is going to start the mentorship batches from 15th December, where you will get personal mentorship, personal guidance for those students who are preparing on themselves or they require some guidance, hand holding in their preparation. Here you will have direct one on one sessions with the faculty members on a weekly basis, and on a monthly basis, you will have one on one sessions with Deepika ma'am. And you will also get complete test series, subject wise sectional tests, subject wise full tests, and also full length tests regarding the UPSC, TGPSC, APPSC. All the exams are covered. For everything you will get the personal mentorship, and also the current affairs are also being provided in this batch. So it is going to start from 15th December, and it is available at a very discounted price. So hurry up and start your journey with Shikara Academy. So let us move to our topic, which is called atmospheric pressure. What is pressure? Pressure is something where the weight exerted on a specific unit area. So if I'm standing over here, then I have a column of air above me which is exerting some pressure on me. It is called atmospheric pressure, weight of column of air at any given place and time. It is measured by using barometer in millibars. The standard sea level pressure is 1013 millibars. And pressure is not uniform across the globe. If the air is descending, the pressure will increase, as in the weight is getting added. If the air is rising above, or in the weight is getting removed, so it will be low pressure. So when the air is descending below, it will be high pressure. When the air is rising above, it will be low pressure. When the temperature is more, the air expands, becoming lesser dense, then it will rise up, creating low pressure. So where we have high temperature, we will have low pressure. When the temperature is low, the air will condense, it will become heavier and it will sit down. So temperature decreases means pressure will increase. So depending on different factors, the pressure is different in different places of the earth. So what are the factors influencing pressure? One is temperature, as we've just seen. When temperature increases, pressure decreases. When temperature decreases, pressure increases. So this is a inverse relationship. So cold regions will have high pressure, hot regions will have low pressure. And then altitude, pressure will decrease with height. Air is denser at sea level, so the dense air is sitting down, right? So at sea level, the denser air is present compared to the upper layers. So as we go up, the pressure will decrease. Similarly, the rotation of earth, rotation causes centrifugal force, and also there is Coriolis effect because of the earth's rotation, which is a pseudo force or apparent force, which redistributes the air masses, creating dynamic pressure belts. We will see how dynamic pressure belts are formed when we see the pressure belts. At the equator region, because the sun is vertically, or majority of the time sun is vertically on the equatorial region, because of this, the region over here is more hotter. Because of this, the air over the equator will keep on rising. Because of this rising, the pressure over here is low pressure. When weight is getting removed from your head, it will create low pressure. And we also have to know one principle that wind will always flow from high pressure to low pressure. So in the equatorial region, when there is low pressure, the winds will come towards the low pressure, they will converge over here and they will rise above. So the winds are coming from different regions towards from northern hemisphere and from southern hemisphere towards equator. And here they will converge, and they will rise above. So this region is called equatorial low pressure belt. It is also called the doldrum region, from 5 degree northern hemisphere, 5 degrees in northern hemisphere to 5 degrees in southern hemisphere. And this belt is created because of temperature. So this belt is thermally induced belt because of intense heating at equatorial region. Air heats up, it expands and rises. It is called convection. Air is heating up, it is expanding and it is rising up. It is called convectional current. So this is a zone where the winds from northern hemisphere and southern hemisphere are converging. Hence it is also called convergence zone. And it is between the Tropic of Cancer and Tropic of Capricorn, because of which it is called intertropical convergence zone. Then we have subtropical high pressure belt. See, the equatorial low pressure belt we have, then we have polar high pressure belt. Here also we have polar high pressure belt. These three belts, they are thermally induced. So if I show you the pressure belts, diagrams of pressure belts, see, this is the equatorial low pressure belt, and this is the polar high pressure belt, and this is also polar high pressure belt. These three pressure belts, 1, 2 and 3, these three pressure belts are thermally induced. Here very high temperature, because of which there is high pressure. Here very cold temperature, because of which there is high pressure. But these two pressure belts in northern hemisphere and southern hemisphere, as in the four pressure belts, are dynamically induced. How dynamically induced? Let us see. If I draw this diagram, this is equator, 0 degrees. Here the air is converging and it is rising above. And here it will get diverted, and it will sink down in this region. So this region where the air is sinking down, here there is pressure created, because of which in this region there is high pressure. So this is called subtropical high pressure belt. So from high pressure, the wind is coming towards low pressure. Now the wind which is sitting over here, it is moving in both directions, and the wind which is coming towards this direction, and from polar region also, if you see, we have polar region. We have high pressure belt, so wind is sitting down, which is moving in this direction. Wait 1 second. This is polar region. Here the wind is sitting down because of high pressure. Now which is coming towards this direction, and here also the sinking air is coming towards this direction. Both will converge here, and here the air will rise, because of which here there will be low pressure. So here we have subpolar low pressure. Even though the temperatures over here are comparatively cooler, but because of the rising of the air, convection of the air, the pressure is low over here. Here, because even the temperatures are warmer over here, because the air is sinking down, here we have high pressure. So we have equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belts. These are the 5 pressure belts, and 4 more in the southern hemisphere. So 4 in the northern hemisphere, 4 in the southern hemisphere, and 3 in the northern hemisphere, 3 in the southern hemisphere, and 1 at the equator. So totally 7 pressure belts, of which 3 are thermally induced, 4 are dynamically induced. So subtropical high pressure belt is around 30 degrees to 35 degrees north and south, both of them. They are formed because of the sinking air at the subsistence air, which is rising at the equator, moving towards this direction, and it is sinking over here. Similarly, it is sinking over here. The sinking region is called the high pressure region. The rising region is called the low pressure region. So these are the three pressure belts which we can see here. So because of high pressure, there are clear skies. When wind rises, it will condense and form clouds. When wind is sitting, it will not condense. There are no clouds, because of which there is clear skies. It is also one reason because of which there are deserts in this region. Then we have subpolar low pressure belts over here, because of the wind which is moving from the polar region and also from this high pressure region, because of which the wind is rising over here, because of which there is low pressure over here. So it is around 60 to 65 degrees north and south. They are also dynamically found, induced because of convergence of warm air of the westerlies and cold air of the polar easterlies. So in this region we see frequent storms because of there is formation of fronts. Frontal formation happens here because of the contrasting air masses. Then we have trade winds. So these are called planetary winds. Those winds which are moving between the subtropical high pressure belt and equatorial low pressure belt in the northern hemisphere and southern hemisphere, they are called the trade winds. And those winds which are flowing between the subtropical high pressure belt and subpolar low pressure belt, they are called westerlies. And those winds moving from polar high pressure belts to subpolar low pressure belt are called easterlies or polar easterlies. These are polar easterlies, these are westerlies, these are trade winds. Now trade winds are also called easterlies, and you know why the winds are diverted in different directions. We have Coriolis force. Because of Coriolis force, winds get deflected towards right in the northern hemisphere and towards left in the southern hemisphere. So if the wind is coming in this direction, it is deflected towards its right. If it is going like this, it will be deflected towards its right. If it is coming like this, it is deflected towards its right. And Coriolis force is maximum at the poles and minimum at the equator. Coriolis force is maximum at the poles and minimum at the equator. Is it clear? Okay. So trade winds are moving from subtropical high pressure to equatorial low pressure. In northern hemisphere, they are called northeast trade winds. In southern hemisphere, they are called southeast trade winds. They are steady and regular winds. They they help in navigation. They help in sailing of ships. They push the ships towards the western direction, because of which they are called trade winds. They used to help the ships in trade. They bring heavy rain to the eastern coast, because when the winds are coming in this direction, they bring heavy rains. Then we have westerlies, which are moving from subtropical high to subpolar low. In southern hemisphere, because the land mass is less, these winds are extremely high and intense. At 40-degree latitude, they are called roaring 40s. At 50-degree latitude, it is called furious 15s, furious 50s. In 60-degree latitude, they are called shrieking 60s. Then we have polar easterlies. They are high latitude winds. They are moving from polar high to subpolar low. They are cold, dry and stable winds blowing from the ice regions, so ice cap regions. So they are moving from northeast to southeast. So their collision with the warmer westerlies lead to formation of fronts. Then let us see the tricircular meridional circulation. So if I am having this globe over here, then at equatorial, the winds over here are from subtropical region, subtropical high pressure belt coming towards towards equator, and they are rising over here, and they are rising over here, and again going in different directions like this. Then again they are descending down. They are descending down. So this cell is called Hadley cell. And the winds over here, they are diverging and they are rising over here, creating this cell. This cell is called Ferrel cell. And this cell which is getting formed over here, this is called polar cell. This is called polar cell. which is sinking at pole. It is coming towards this direction and rising at the subpolar low pressure belt. So this cell is called polar cell. So these are the three cells. And if you see, if you talk about jet streams also, they flow at the margins of these poles. So here the wind is rising, it is moving, and it is sinking. It is moving in different directions, rising and at poles it is sinking. So this is Hadley cell, Ferrel cell, and polar cell. Hadley cell named after George Hadley. It is a closed circulation. Air rising at ITCZ creating low pressure. If you talk about Ferrel cell and polar cells, they are the Ferrel cell which is sinking at the around 30 degrees north, moving and rising at the subpolar low pressure belt. And polar cell, where the air is sinking at polar region, it is coming towards the subpolar low pressure belt and it is rising towards subpolar low pressure belt. So this makes the polar cell and Ferrel cell. And also the pressure belts are not constant. We know because of the tilt of the earth is moving revolving around the sun. So there is apparent movement of sun. When the sun is shifted towards the northern hemisphere, the pressure belts is also shift towards north. When the sun is shifting towards southern hemisphere, the pressure belts also shift towards southern hemisphere. So around 5 to 10 degrees of shift happens in the pressure belts. Let us look into some of the important local winds. We have land and sea breezes. See, land warms up faster and cools down faster compared to water. So daytime the land is more warmer, hence we have low pressure, and comparatively we have high pressure over water, because of which wind moves from ocean to the land. It is called sea breeze. And during night time the land is cooling down faster, creating high pressure, and on oceans it is low pressure. So the wind moves from land towards ocean. So it is called land breeze. We have some more local winds like Chinook and Fohn. They are warm, dry winds. They are also called snow eaters, because when the wind is moving towards a mountain and it is rising up, it will get condensed and it will lead to rainfall. And on the other side, when it is traveling, it is dry. And as the height decreases, the temperature will increase. As the height increases, temperature will decrease, and as the height decreases, temperature will increase, because of which this is a warm and dry wind, because it has lost its moisture on the other side of the mountain. So this Chinook wind and Fohn wind are found in, Chinook winds are found in the Rockies area, Rocky Mountain area of USA. Fohn winds are found in the Alps mountains in Europe. So they have similar characteristics. They will melt the snow in this region, and they will help the farmers over there, herders over there, to have proper grasses which are useful for fodder for their cattle. If you look at the African region, from the Sahara Desert, we have winds like Sirocco, Harmattan moving in these directions. So Sirocco winds, they bring dusty conditions, warm conditions. They blow from Sahara to Mediterranean region. So here we have Mediterranean Sea, and here we have Europe. So they bring dusty conditions, hot winds towards this European region. It also lead to blood rain in the region of Italy and Spain because of the dust particles, red colored dust particles which are present in the clouds. When they rain, the rain looks like reddish tint. Harmattan wind is also called doctor wind. This is the equatorial region. Because of this, there is frequent high moisture present over here, high rainfall over there, because of which the place is having more diseases. When these dry winds come to this region, they will take up this moisture and they will go, because of which they will bring relief to this region, because of which Harmattan winds are called doctor winds, which are into the West African coast, in the equatorial West Africa. Then we have some cold winds in the Europe like Mistral and Bora. They are blowing from Alps to the Rhone Valley towards the Mediterranean Sea. They can be very violent and also can damage crops. Whereas Bora, they blow from mountains towards the eastern shores of Adriatic Sea. They are also known for their gusts of winds. So we have Chinook Foen. They are in the Rocky Mountains. Chinook Alps Mountains is Foen. Rocky in USA, Alps in Europe. They are warm and dry. Sirocco or Khamsin, they are in the northern Africa towards Mediterranean Sea and Europe or Egypt. They are hot and dusty. Harmattan are also warm winds to going towards West Africa or the equatorial West Africa. They are also called doctor winds. They are dry. Loo is present in northwest India. It is a hot wave in India during summers. Mistral or Bora are cold winds in the European region, in Rhone Valley or Adriatic Sea region. Pampero is in Pampas region of Argentina. It is also a cold wind. Blizzards are present in the polar regions of USA, Russia. They are cold and snowy. So these are some of the important topics in your pressure belts, planetary winds and local winds. So we'll end the lecture over here. Thank you all. We'll meet in the next video.